Okay, so welcome to our rivers lesson. Today we're going to look at the river long profile, see how the river changes from source to mouth. You'll need something to write with, pen, paper, just to write any new information or make any annotations as we go through. And our three key takeaway points we're basically aiming to do are to describe the changes of the river along the profile, so what characteristics are changing, to explain why these changes happen, and then to try and link some of the landforms to the processes that we see in the river to basically show our understanding of how those rivers are changing from source to mouth. So first of all, what we're looking at is how the long profile changes in terms of its river characteristic from source to mouth. And we need to examine these changes and begin put some explanations to them. So the first part we're going to look at is how our river changes from source to mouth. Now we have two images from the left and to the right. So the image on the right is our start of the river, or what we call the source. And the image on the left is what we call the mouth of the river, or the end of the river. Now you can take a few moments just to look at the characteristics of these images. Think about what the river looks like, think about the water that it's carrying, think about the surrounding landscape as well. And you can also use that diagram which shows the long profile just below, where we can see it's divided between upper, middle and lower course. So image on the left would be our source, which looks like it's going to be in the upper course. The image on the right is the mouth. That's our end of the river, and that looks like that part of the river is nearer to the lower course of the river. So hopefully you're taking in a few points as we look through. Just to highlight a few characteristics, I'll just mark these in red. Just consider this part of the river compared to this part of the river. Also consider that change there. Okay, now we need to make an assumption, but we're going to make the assumption based on how that is different. Also, you might want to look at the surrounding landscape, maybe look at the fact there's a clear profile and it's relatively flat over there. So that's the yellow showing the surrounding land. So you can match these changes based on the diagram that we have as well, showing how the river changes from source to mouth. So hopefully there are a few characteristics that you can identify are changing. Okay, so first of all, it looks like the image on the left, the river is really narrow. The image on the right shows that the river is much, much wider. So what we can say is that the river width increases downstream. Just put in brackets that it becomes wider. Okay, so the width is getting bigger. Okay, we can also see that the river in the upper course, we can see that there's a visual drop in height. So the river is cutting downwards. And this is where we can see that drop in height. So following on from that point, we can visually see that drop in height. So this is called, and I'll put in brackets after, vertical erosion. So this is the river trying to cut downwards, whereas the image on the right isn't cutting downwards. Okay. Now the opposite, because it's not cutting downwards, because it's nearer to its end goal, which is the sea level, because it's not cutting downwards, you'll actually find that it's not vertical erosion taking place, but a sidewards erosion called lateral erosion. Okay, so lateral erosion is this sidewards erosion. Okay, so that's one thing worth bearing in mind. So the image on the left, we can see that visual drop in height. The image on the right is much, much flatter. Okay, so this is the same with the surrounding terrain. So on the image on the left, that yellow line shows that steep profile, that steep gradient, and the image on the right shows flat land or a flatter gradient. So the gradient of land becomes flatter. Okay, so that's a key observation there. Okay, so where we can see white water, just by where the water's dropping, you can see white water represents friction. It's basically rubbing and mixing against the channel bed. Okay, so here we can see that the channel bed is shallow. Okay, it's not very deep, and that's because we're having white water as it runs over stones. So channel bed is shallow and it's rough, it's not smooth, creating that little bit of white water. Whereas downstream, we can see the image on the right shows that it's much, there isn't any white water. You can see a huge amount of water being carried, large volume of it. So we're making the assumption that it is also deeper and has a smoother channel. Now we can't see that because of the water being so murky, but we're making that assumption that it's changed because we can see the huge transport ship can fit in this river. So we're making the assumption that actually it's going to be deeper than the image on the right. So far, what we've noticed, and I'll just see if I can highlight these, is that the width increases. We can also see that the land becomes flatter. So the image further down becomes deeper, and it has a smoother channel as well. Okay, so these are key characteristics that we can identify. Now, if we look towards the long profile, okay, the diagram, so these become a little bit clearer. We can see that the gradient changes, it becomes flatter. We can also see that the river begins to bend near the end. These bends are called meanders, okay, and they're a sign that the river doesn't need to cut downwards anymore. It's cutting laterally or sidewards, okay. So this shows lateral erosion taking place. So that's another form of evidence. So we can see the river begins to bend, and I'll highlight this part down here. So it begins to end. So it's gone from vertical erosion to sidewards lateral erosion. And that's why we can see these bends that are literally here, okay, from the end of the middle course to the lower course. So we've got a significant change there, okay. So we can see all of these changes as we go from start to finish, okay. So wider, it's deeper, it becomes smoother channel bed, it becomes flatter. and we can assume that the volume of water is getting higher, and therefore also the power of the river is increasing. So what we need to do is just pull together a reason why this is happening. So for this, we'll come to this diagram, okay? And this diagram will basically try to explain what is happening. So from that image on the left, where it's small, not a lot of water, to that image on the right, the water's got to come from somewhere, okay? So ultimately, there is never just one source for a river. There'll be quite a few different sources for a river, okay? Different points from where it comes from. Now this will contribute water to the main channel. So all of these little streams are called tributaries, just there. That will be another one. This will be one. They're all tributaries. So they're taking a small bit of water towards the main channel, the main river that will drain that whole area, hence the word drainage basin. Now, as we go along, what we start to see is there's several points where the rivers meet or join. There, 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 and there. And all of these points are known as confluences. And confluences are where the volume of water is increasing because two streams merge and they combine their water loads together. So every time they meet at these points, the volume of water is basically amplified, it doubles, okay? Now, with more water comes more power, and with more power, the river can begin to erode a bigger, wider, and deeper channel. So this is a point worth making a note of. So there are several sources to a river. As they meet, I'll put confluence next to it, the point where they meet. They add water volumes together. Each time this happens, the river's power increases because of that greater volume of water, which allows the river to erode a wider and deeper channel for itself. Otherwise, the water would always flood at these points, okay? So that increase in water volume will give the river more power to erode a bigger and wider channel for itself, okay? So that's the reason why this volume of water is getting bigger and why the river characteristics change from source to mouth. So we'll come to the last part, which is basically where can we associate all of these different landforms. So there are 6 landforms on there, and we want to try and identify where they come along here, whether they're going to be in the upper course, middle course, or lower course. And I've got 3 colors for to segregate those 3 different sections. So you can look at those images, think about the characteristics that the river was shown at the upper, middle, and lower course, and you've got the diagram to help prompt you as well. But think about where these landforms might be found. So you can take 20 seconds or so, just think about where these landforms will be found, and then we'll pick through the ideas just before the end, starting with the upper course. So think about the characteristics, think about the shape of the land, think about the size of the river. Use the evidence around you to try and identify where these are found. Think, is it vertical erosion? Is it lateral erosion? So we'll start. So first of all, the upper course. Waterfalls would be part of the upper course because they clearly show vertical erosion, steep terrain in the image. Okay, so and there's white water as well, but we can see a visual vertical erosion taking place. There's a drop in the height. Interlocking spurs. They are upper course landforms because we can same again see the steep terrain. The river doesn't have energy to erode through those outcrops of rock, so it has to go around. But if we didn't know that, we know that it's steep terrain, so it's got to be in the upper course. Of course, our source of the river is where it all comes from, but we can see the river, there isn't really much to it, okay? Not a significant flow. And then if we didn't see that, we can see that the land around the river is relatively flat as well. And the rapids. Now, rapids can transition from upper to middle, but we can still see white water, a rough channel bed, and we can see that is relatively narrow as well. But we can see the stepped gradient. There's about 3 steps there, so we know it's still trying to cut downwards. So what I'll do is I'll just put that in. Sometimes they transition down to the middle course. Okay. So in terms of our middle course landforms, this is where we're starting with our meanders, but meanders can also move, so they will migrate towards the lower course of the river. So they can be found middle to lower course because that's where lateral erosion has taken place. So the river's not cutting downwards anymore. There's flat land, so it's going to erode sidewards, and that creates these bends in the river. Okay, so this creates this meandering of the river from the middle to the lower course as it migrates. And then our final one is levees. These are these mounds that are built either side of the river channel. So even if we're not sure where they are, we can use the features around them to identify where this could be. So we can see it's flat land, okay? We can make the assumption that it's farmland, but otherwise we can see that it's flat land, and we can see that the river is wide. There's not much white water. It is very flat, and it's actually bending round to the right. So we can make the assumption that these levees will be formed in the lower course of the river. So hopefully that's run through the changes and some of the landforms and given you reasons why the river changes. So just to end, we'll clear those drawings. So quick recap from our 3 key takeaway points. We wanted to describe the changes along the river's profile, so we are aware that it's becoming wider, deeper, faster, more powerful. Okay, and why was that happening? Because we have loads of these little streams, tributaries that are adding their water to the main channel. And the more that they add water to the main channel, the more the power of the river increases to erode a river channel that's wider and deeper. And then the final point, to link the processes to some of the landforms found along the river profile. So obviously where the river is less powerful, narrower, shallower, and vertically trying to erode downwards, we're going to find source of the river, waterfall, rapids, and interlocking spurs. Where the energy is picking up and there's more lateral erosion taking place, we might find features like meanders and levees. Okay, hopefully that's been useful for you, and we'll look at some of the other landforms in another lesson. Take care and have a good day.